we are going to finish 6.5. Okay, let me behind that. Whew. So there's 6.5. Okay, so I got confused in the end of the last video because usually whenever I have a 3x4, what I'm going to do is actually the Gauss-Jordan elimination method. And my confusion came from like the fact that we haven't really covered that yet in this class. And then I remembered that we actually do 6.5 and then we go back and do 6.1. 6.1 is where you learn how to do that work. And so that's why I got confused. Y'all just haven't learned this other method to solve this matricing. And so we're going to do what it says, of course, which is using Cramer's rule. It's going to be very similar to the other 6.5 video that we did. I guess it would be part 2. But because this isn't, it's called a square matrix, right? So if it's a 2x2, that's a square matrix. A 3x3 would be a square matrix because like that would be a 3x3, right? Like those, you got the same length and width. And then a 2x2, that would be a square matrix. So a 3x4 is not considered a square matrix because there are more columns than there is rows. So the process is going to be slightly different. I'm going to probably have to zoom out and just try to keep this as straight and helpful as possible, honestly. Okay, so the way that you're going to find the answer to this one using Cramer's rule, right? Our goal is to solve for X, Y, and Z. Now, there's going to be, let me show you instead of just saying it. Okay, so this is how we found the determinant of our 3x3 matrix, right? Those were called minor determinants, and we identified what all these different parts were. And then we went ahead and did those steps right there, and we get the determinant, right? There, it didn't actually have me solve for X, Y, and Z, right? Because this would be X column, that would be the Y column, that would be the Z column. It didn't actually have me solve for those variables to see what would make the equations true because I only had a 3x3 matrix. I didn't have an equal column, which would be, this equation equals, whatever's on the right-hand side of the equal sign. Because it's not in that form, I'm not actually solving for X, Y, and Z. So I just take the determinant, and that's your answer. Well, for this second problem right here, I still have technically a 3x3 right here, but this is actually a system of equations. We have 3 equations. I do have an equal sign on the right-hand side. And so I'm going to actually solve, right? When it says solve, that means we're finding our variables. So here I'm going to actually solve for X, Y, and Z. So the way we're going to do that is we're going to need to know what the determinant is. And we're actually going to take the determinant of this right here. Okay, and the reason why I know I'm going to take the determinant of that is because that's going to be a 3x3, and this is what you use to find the determinant. I'm going to try to say easier ways instead of sub 1, sub 2 every single time. I know that first column is going to be my A's, and y'all, it goes A sub 1, 2, 3, right? Column 2 is my B's, goes down 1, 2, 3. Column 3 is my C's. So there's a pattern there. Okay, if you notice a pattern, it's always good to try to simplify a problem wherever possible. Okay, so I know that that's the form of how to solve the determinant. And so I'm going to zoom out, y'all. So let's go ahead and let's find the determinant of this matrix. Okay, I know that it's A column, and then the second column is B's, and the third column is C's. What you do is you just pull the coefficients. What I would have is 1, 8, -1, 1, -1, 4, and then 1, 1, -1. Okay, and then I know that what I need to do, because we're finding the determinant of a 3 by 3 matrix, is to actually use our minor determinants. And so to solve for this, remember what we did was we looked at our column 1 right here. Those are the coefficients of each individual determinant that I took. And so I would have, that's going to be 1 and then times. When you cover up its column and its row, you're going to take the determinant of what is remaining right here, what's not covered up. Okay. And so what we're going to do is we're going to take the determinant of, I'm trying to look, I actually did all of the work, so I'll go and do it now also. So we're going to start here. We have 1 and then times the determinant of -1, 1, 4, -1. I did it again, man. Close that. This is where we alternate plus, minus, plus, minus, plus, negative, positive, negative. We would take a -8, and we're going to multiply that by the determinant of 1, 1, 4, -1. Really hard to write on this laptop the way I have it. And then we're going to alternate back to positive, but because this is a -1, we just have -1 times the determinant of 1, 1, -1, 1. Okay, so let me go ahead and do this. I would have 1 times the determinant here would be -1 times -1 minus 4 times 1. Then we have a -8 times the determinant here is 1 times the -1 minus 4 times 1, close, negative times this determinant, which is 1 times 1 minus a -1 times 1. And so what we get here, 1 times 1 is 1, signs are the same, so it's positive. 4 times, excuse me, 4 times 1 is 4, signs are different, so it's negative. We have our -8, open up your bracket. 1 times 1 is 1, signs are different, so it's negative. 4 times 1 is 4, signs are different, so it's negative. Subtract from that. What's going on here, which is 1 times 1 is 1. Signs are the same, so it's positive. And then here I have 1 times 1 is 1. Signs are different, so it's negative. And then times that other negative makes it a positive 1. So continuing to solve this, what I would get is 1 minus 4. Those signs are different, so you subtract and keep the sign of the larger. And then I have a -8 times -1 and -4. Signs are the same, so you add and you keep the sign. Then we're going to subtract from that the sum of 1 and 1, which is just 2. And so here I need to do that multiplication first. So I've got -3, 8 times 5 is 40. Signs are different, so it's negative. And we have a -2. I'm going to move this way, y'all. Signs are the same, so it's positive. And then we have a -2. And so now, working left to right, same way you would read a book, we have a -3 plus a, nope, yeah, -3 and a positive 40. Because those signs are different, what we do is we subtract. Sorry, let me get this real quick. Is we subtract and we get 37. Keep the sign of the larger, so that's a positive 37. Then we have a -2, 35, and combined with the -2. Why did I say 35? See, I did it again. I knew what I was going to. 37 minus 2 equals 35. That's the determinant of that problem right there, of that matrix, okay? So that's about a quarter of the work needed to solve this problem, okay? So what we're going to do now is I'm going to actually explain to you what we use to find our x, our y, and our z, okay? What I just did, we've already done before in the previous video, so hopefully that was well understood. Now let's learn how to take, how to solve for x, y, and z. Okay, the way you solve for your x, what we're actually going to do, I feel like I want to use this. We'll see. what we're actually going to do is d sub x, okay? What you use to solve this is we're actually going to take the determinant, okay? This first column is going to be my d's, second column will be b's, third columns will be c's. I'm going to read this one like technically, okay? I have d sub 1, b sub 1, c sub 1, d sub 2, b sub 2, c sub 2, d sub 3, b sub 3, c sub 3. Okay, and y'all, this is my A column, that is my B column, that is my C column, and that is my D column, correct? So to find x, we're going to take d sub x, and we're going to actually plug in all of these values based off of what they are in the original equation, and then we're literally going to do what we just did right here, okay? So the thing is, okay, so that's how to find the determinant of x. Let me go ahead and write we're going to find that, right? And then our actual x value, right, like x equals, is going to come from what we find when we take d sub x, and we're going to divide it by our determinant. And then that numerical answer is going to be what our x variable equals. Okay, so we do what we just did, but then like there's that one little extra step there at the end, okay? So I'm going to go ahead and show y'all how to find y, and then how to find z, and then we'll actually start working on them. So to find y, one of the steps that we're going to do is find d sub y, and d sub y is going to be a dc. So I see a pattern, I'm going to go ahead and do it, d c. Y'all see what I mean by I see a pattern, right? A, D, C, those are my columns, and the numbers are increasing as you go down in the rows. So I could just quickly throw that up there. My actual Y is going to come from taking what I find with my D sub Y, and I'm going to divide it by my determinant, right, which we just found, which is 35. The numerical value I get there is going to be the answer to my Y variable. Now let's do D sub C. The way we're going to find this is A, B, D. So I did it again, y'all. My column 1 is my A. My column 2 will be my B. My column 3 should be my D's. The reason why I know that, y'all, honestly, it's because I've been doing this for years. But the reason why I know that is because my actual D values, my D column values, they shift from being in column 1, column 2, column 3. Okay? And so because, let me show y'all this. It's actually quite easy to remember. Because when I do D sub x, my D column is first. That replaced what would usually be there, right? Which is my A's. And so the remaining columns are just what they always would be, B and C, right? My D's now my A's. What's left is B and C. Now, if you look at D sub y, my D shifted. Now it's in the middle column. So it's taking the place of my B column, correct? And then you just fill in with what would already be there, A and C, right? A would be the first row, C would be the third row. Now, if you look at D sub Z, my D is now in my third column. So it has replaced my C's, and what's remaining, just normally where they would usually go, my A and my B's. Does that make sense, y'all? Okay, that's what's happening there. Okay, and then the very last step, the way we're going to find the actual value of Z is to take our D sub Z and divide it by our determinant. Okay, so like I said, column D is the first column for D sub X, it's the second column for D sub Y, and it's the third column for D sub Z. you could actually go ahead and do those first, right? 1, 2, 3 column, and then fill in what goes like in the appropriate places, because D is here, BC goes here. Because D is here, AC goes here, right? Okay. Now that we know what we need to be able to actually start working and figure out our X, we're going to do that one, then Y, then Z, and I'm going to just kind of plug those values into at least one of the originals. If you need to check yourself, I would plug them into all of the originals, but time-wise, I know this problem is going to take forever to do. So let's go and get started. Okay, so what I'm going to work on first is my D sub X. I still don't have this problem solved. I'm going to actually look DBC. I wonder if there's a way. Let's copy this. Did I copy it? And then let's actually move right here. Paste that. I want to move it slightly at least. The whole thing is not highlighted again. Hold on. At least that kind of shows me the values, right? And like I said, y'all, it goes in order alphabetically, A, B, C, D. I know that because this is X, look here also, it's my X values, right? That's where my D's go. So my D's are 0, negative 45, negative 10. Oh my goodness gracious. And then this goes in the order of A, B, C. So now I do my B and then my C. My B is 1, negative 1, 4. My C is 1, 1, negative 1, close. We need to actually find the determinant of this. Okay, y'all. So I'm not going to keep doing every single step, okay, because we've been doing that. I notice here that this is where I alternate, right? So positive, negative, positive. I would start with the values in my column 1 because that row 1, column 1 is a 0. It's going to be 0 times the determinant of whatever, but 0 times anything is 0, right? So I'm just going to kind of move on to the next value. Because I am moving to the second, what I do is take negative, right? Positive, negative, positive. It's going to be a negative 45. And this is actually going to be multiplied with the determinant. And what I would have here is 1 times a negative 1 minus a 4 times 1. And then we would do addition here, but because that's a negative 10, we just write negative 10. And that's going to be negative 10 times the determinant. And my determinant here would be 1 times 1 minus a negative 1 times 1. Okay, so what I have here is a negative, I didn't do that 45 there. I put that in parentheses because it's supposed to be a negative 45. So negative and a negative makes it a positive 45 times, okay, so I have 1 times 1 is 1, signs are different, so it's negative. 4 times 1 is 4, signs are different, so it's negative, close, right? I haven't evaluated that just yet, but that's where I'm going. Then I have a negative 10 times 1 times 1 is 1, signs are the same, so it's positive. 1 times 1 is 1, signs are different, so it's negative, and then that other negative makes it a positive. So technically what I have here is 45 times, those signs are the same, so you add and you keep the sign, and then negative 10, signs are the same, add and keep. 45, where's my calculator? Is it like 200? 5 times 5 is 25. 4 times 5 is 20. 5 times 5 is 25. Should be 225. A negative 225. Okay, 45 times negative 5, negative 225. And then here I get 10 times 2 is 20. Signs are different, so it's negative. Y'all, I'm at like the craziest angle. Y'all should see me. And then, y'all, if you combine those together, the signs are the same. So you literally just add them together and keep their sign. This is what equals my D sub X, correct? Now, in order to actually find X, what I do is I take my D sub X and I divide by my d. And if you do negative 245 divided by 35, what you get is a negative 7. That equals my x. See? Easy peasy lemon squeezy. Let's do our, kind of can't see everything, but maybe we can like that. Let's do our d sub y. I know that my d column in the original equation shifts from column 1, column 2, column 3 as I continue, right? So my 0, negative 45, negative 10 is going to be here. My a's, of course, would be the first column, and it is 1, 8, negative 1. Is that correct? 1, 8, negative 1, yeah. And then my c is, well, it's the same c that's right here. So it's 1, 1, negative 1. Let's go ahead and do this math. I have 1 times the determinant. So that's actually going to be just negative 45 times a negative 1 minus a negative 10. I just kind of give up on that button. I don't know what it is. That's times 1, close. Then we're going to alternate our signs, take a negative 8, open. The determinant would be 0 times a negative 1 minus a negative 10 times 1. And then we would alternate again, and we would get positive, but because it's a negative 1, we just write negative. Times the determinant would be 0 times 1 minus a negative 45 times 1. Okay, so I'm just checking my math. Negative 45, negative 1, minus negative 10, 1, 0, negative 1, negative, negative 10, 1, 0, 1, negative, negative. Okay, I just make sure I'm good. Okay, so continuing with this, y'all, you got 45 times 1, which is 45. Signs are the same, so it's a positive 45. And then I've got 10 times 1 is 10. Signs are different, so it's negative. Negative, though, times a negative gives you a positive, close that, negative 8 times Cameron. Oh, never mind. I was going to turn the AC up. I'm freezing. 0 times 1 is just 0. Doesn't matter about the signs because 0 is 0. 10 times 1 is 10. Signs are different, so it's negative. Times another negative makes it a positive. Then we have a negative. 0 times 1 is 0. 45 times 1 is 45. Signs are different, so it's negative. And then multiplied by another negative, you just get a positive 45. And so what we have here is, that would be 55. That doesn't seem right. Yeah, that's right. 55. Oh, that's why. This looked like something weird. It's an equal sign. My bad. That would be 55. And then 0 plus 10 is just 10. It's positive 10. 10 times 8 is 80. Signs are different, so it's negative. And then we have a negative 45. Using my calculator, if I do 5 minus 80 minus 45, what I get is a negative 70, which is my d sub y. In order to actually solve for y, I need to do d sub y divided by d. That's going to be 2. Signs are different, so it's negative. That's my y. Does that make sense, y'all? Okay, let's do d sub z. Remember what I said about that d column? It shifts. First column, second column. Now it's in the third column. And so I fill in here my a and my b because that's where they would go. So my a's, I'm actually just going to look up to d sub y because I was able to fill in a here, which is 1, a, negative 1. That was my d, so I'm not going to use that. But here I could actually use my b, which is 1, negative 1, 4. Now let's go. So 1 times the determinant, which is going to be a negative 1 times a negative 10. Subtract from that 4 times a negative 45, close. Alternate, I get a negative 8. The determinant of that is going to be 1 times a negative 10. Subtract from that 4 times 0, close. I would alternate to a positive, but it already is a negative. Then I would multiply that by 1 times negative 10, trying to write slow, and then subtract from that 4 times 0. So now what I have here, 1 times 10 is 10. Signs are the same, so it's positive. Get my little calculator here. So I'm looking over my work. My 1 times 10, 445. Okay. Okay, so first, okay. I should have checked before I moved on to the next step, sorry. 4 times 45 is 180. Signs are the same, so it's a positive 180, right? And then close that, negative 8 times 1 times 10 is 10. Signs are different, so it's negative. 4 times 0 is 0. I just went ahead and wrote the negative. It really doesn't matter, y'all. And then we're going to subtract from that, negative, open. 1 times 10 is 10. Signs are different, so it's negative. And then 4 times 0 is 0. And then what we get here, those signs are the same. We add and we keep, right? We're going to get 190. And then negative 10, negative 0, those signs are the same. You'd add and keep, so I got a negative 10, right? And then 8 times 10 is 80. Signs are the same, so it's positive. And then same thing here, I get a negative 10, but a negative times a negative 10 is a positive 10. And so, let me just double check this, because this is not a good problem to mess up on. I have to go back, so I want to check each step. I just want to make sure. So 1 is here. This is my determinant. 1, negative 10, 4, negative 45. And then I get my 8. My 8. This is what I take the determinant of. 1, negative 10 minus 4, 0. Yep. I'm just checking my math, y'all. And then here I get a negative 1. This determinant would be here. Oh, what was I looking at? I don't know what I was looking at. So look it, already messed up, but I found it, so we're good. This right here, I just see where this is going, and I know that, look, y'all, my brain was thinking, I've got a negative 2, right? And I got a negative 7, negative 2, negative 2. If I don't let me mark on it, negative 2, negative 7. If I'm trying to get to 0, that needs to be a 9, right? Because negative 2, negative 7 is negative 9 plus 9 gives 0. Well, I know that if I add all of these up and divide by 35, I'm not getting 9. So that's why I wanted to really look and see, like, I'm positive there was a mistake. Okay. What are you doing, boo? So we're going to do this determinant right here. Okay. And I'm here, which means I'm looking at this determinant. That is 1 times a negative 45. I'm sure y'all were all screaming and yelling and gave up and got really mad at me right there, and I apologize. And then subtract from that a negative 1 times 0, which means that this is going to change right here. Okay, and so what we're going to end up having is 1 times 45 is 45. Signs are different, so it's negative. 1 times 0 is 0, just 0, right? And so that means that this changes right here. We have a positive 45 because negative 45 and then times that negative. It just always knows the perfect time to do that, right? And so we get a positive 45. Now, mental math in my head, that looks more like it as far as getting 9. And that's because if you do 190 plus 80 plus 45, we get 315, which is our d sub z. And I know I need to take d sub z divided by d. What I get if I divide 315 by 35, that's 9. Okay, that's my actual z. Okay. So what I'm going to do now, we already found all of our x, y's, and z's, right? TBH, if that was my only mess up, like, that's a good mess up because it was the only one. I get -7, -2, Z. Now, as far as the final answer is concerned, you would have -7, -2, 9, right? Now, if you look back up here again, I've got plus x plus y plus z equals 0. So this is saying add x and y and z to get 0. Y'all, this is plus a -2, right? But there's no reason to write double operations. And so if you do -7 and -2, signs are the same. So you add and you keep, then bring down our +9. Additive inverses, we get 0 equals 0. And if you plug these values into these other two equations, you will also get them with true statements, right? Because those are the values. And so -45 will equal -45, -10 will equal -10. I do apologize for that one little mess up, but I hope that makes sense as far as how to solve this actual system written in actual equation form using Cramer's rule. Okay, so if y'all have any questions, make sure y'all ask. Okay, thanks. Bye.